So thank you very much for having me. I'm Portuguese, but as you're seeing, I'm speaking in English. I was told that there's a sizable international audience here, and so I'll conduct my speech in English. My story starts in 1997, when Michael Cox and David Ellsworth started trying to visualize large data sets of gases coming out of airplanes using data. Now, the problem was that they had so much data coming their way that it wouldn't fit the memory of their computers, local disk, or remote drives that they had. Now, for them, at NASA in '97, a big data problem was 100 gigabytes of information. I've just reached my phone from my pocket. I have 256 gigabytes in my hand. My phone's almost full, and it can deal with them just fine. So over the past 20 years, something magic happened. The problem of data escalated. Now, if I tell you that a tiny ant, which is a small animal in the physical world, would correspond to 1 megabyte of information, then a small person, a short person, would be about 1 gigabyte. Then how much data we are generating nowadays, every day according to Cisco, is about exabytes of data, which is the diameter of the sun, in relative terms. So not only are we generating more data than ever before, data is coming from multiple sources at fast speeds. So we now have data from videos that we post online, from queries that we make, from posts and images that we share in social media, from emails that we exchange with our colleagues. Now, there's a big problem here, an engineering one, which is the majority of the data that we're generating today is what I would call unstructured data. Now, traditional IT departments in most firms have database systems designed to handle data that comes in the form of tables, and that can be specified beforehand at the time where requirements are specified. Now, the data that we're generating doesn't fit this computing paradigm. So whenever firms want to merge their corporate repositories with these large repositories of data that come fast, unstructured from multiple sources, they have engineering challenges. So whenever firms have problems with these three axes, they'll need specialized software tools. Now, fortunately for most firms, Google solved the engineering challenges of big data back in the early 2000s. So if you think about Google's business model, is one where we type a query on a small search box, and it has to match our text to this enormous repository of data online where we have images, video, sound, and it has to give us relevant output. So Google had a big data problem when NASA had a 100 gigabyte problem. Now, fortunately for most of us, Google released the white papers for their innovations online. They didn't give us their software, but they did give us the layout of how to design the software. And competitors from the Silicon Valley area, in particular Yahoo, started developing an ecosystem of open source tools that most firms could access and deploy in their own premises, something called the Hadoop ecosystem. Now, today, firms are increasingly adopting these tools for their business. What I'm showing you over here is the evolution of the revenues of this sector from 2011 until today and forecasted going forward. I have three messages I would like to highlight in this plot. So nowadays, most firms are spending a lot in computation and storage, which makes sense if we need to handle large repositories of data. Firms are also spending a lot of money in something called professional services. These are costs that firms have to deploy and maintain these technologies, which are oftentimes externalized outside the boundaries of the firm. Now, the last message that I'd like to show you from this plot is that that function that would transform data into value for firms, analytics, is only that navy blue part over there. So even as of 2018, about 18 years after this revolution started, we are all only learning of how to use data in order to generate insights for business. But it's here that we expect the trend to grow in the future years to come. Now, if I turn to corporate America, to large corporations, and I ask their CEOs, what are they doing regarding their big data investments, they'll say, we are accelerating them, and we see it as a source of future disruption for our business. If I try to show you data for Portugal, our numbers are much smaller. So according to INE, the average deployment of big data in our firms is around 7.5% as of 2017. And if we split this by firm size, our large corporations, those that have more than 250 employees, have a penetration of these tools of about 30%. Now, if we go back to our corporate America and we ask them, you are accelerating their investments, but are you succeeding? They'll say we're failing. We are failing to become data-driven because we don't have data-driven cultures. We don't have data decision-driven processes in our operations. And we are not really treating data as a business asset, as we do with other assets in our business operations. And we also don't see ourselves as really competing in analytics. When you go and ask them, so why that's the case? They'll not tell you it's a technology problem, because this they can buy. They'll tell you it's a management problem. Culture changes in processes and people. Now, it's a problem for me because I'm the technologist, okay? So the majority of the problem, I don't know how to deal with. Now, if this is such a half-empty picture that I'm depicting, is there any evidence that firms are actually getting returns from these types of investments? And the answer is yes, there's some. There are already a few studies that show that investments in big data operations and software does increase productivity for firms. I'm highlighting only one study, which is a study that brings key learnings which I think are essential. So Sonny Tambe, which was a professor at NYU when he did it, and now he's at Wharton, he studied the productivity of firms in the early days of the technology, from 2005 to 2011. What he finds out is that compared to firms that didn't invest in these technologies, those that did early had a higher growth in value added, measured as the value of sales minus the cost of goods sold. Now, not all the firms got returns from their investments in these technologies. Only those that had sizable data assets themselves. So unless you have large repositories of data coming fast that was unstructured, investing in big data didn't help. Now, also you needed to have specialized human capital that could handle these technologies in-house. So if you were the one externalizing everything, it didn't work for you. Now, the third and very important component was that only firms that already had a culture of driving insights and changing business practices based on data were those getting the benefits from the technology. If you didn't do that, it didn't work for you. Now, so let me pause for a moment and tell you what are, in my view, the three pillars that firms have to have in order to drive value from data. Well, they have to sort out their engineering function for sure. If they have an engineering problem to solve, they'll need the engineering tools. And that's very important. Collecting, storing, and making data available for analytics is very different than collecting, storing, and managing data for accounting. These are completely different worlds. Now, as long as you have the data problem solved, you need to make it available for those that will transform it into things that could be insightful for business. And this is this data science profession that's nowadays emerging. And here, what people do is essentially two things. Number one, they use data for prediction. Number two, they use data for building causal models of the world that will help them anticipate how business changes of processes and actions will outcome. And then, of course, you need business decision leaders that will take your inputs and change the way they're doing business. Now, I'm going to focus the rest of my talk over here, which is really what I know about. So what happens when a firm wants to deploy data science within? Typically, what I've seen is that firms map their business processes onto tasks, searching for uncertainty. Uncertainty is key. Uncertainty is at the core of why management is hard, but is also at the core of why prediction technologies help. So data science helps us reducing the uncertainty in tasks in business that are not certain. At the same time, data science helps us judge our actions based on the predictions that we make. either through experimentation or through models derived from business insights that we take. Now, focusing on the prediction domain over here, what happens? So we hear a lot of AI in the news. Now, truth be told, when you hear AI, you should really be translating those words into supervised machine learning. Because nowadays, the only domain of AI, or the domain of AI that's actually generating value for business, is this thing called supervised machine learning. So what is supervised machine learning? Supervised machine learning is a subdomain of machine learning, because there are others, which in turn is a subdomain of AI, this ideal that we could build machines such as ourselves. In supervised machine learning, we give two things to the machine: input data, in my example, a dog, and output data, in my example, a label. And by showing examples to the machine will learn how to map inputs into outputs, and that's all it does. Learning by example, a set of patterns that generalize. Now, this is yesterday's news. Because if I really want to be precise, supervised machine learning existed since we have regression analysis in the 19th century, and even since we have the Bayes rule in the 18th century. So why now? Why is the media picking up on this right now? Well, it turns that three things happen over the last 10 years. More data, faster computers, and some algorithmic innovation. Some algorithmic innovation. What happens is that more data improves the predictive performance of supervised learning algorithms. If these machines learn by example, the more examples you show them, the better they learn. At the same time, people like the Turing Awards this year, so Yann LeCun, Yoshe Benju, and Jeff Hinton invented some tweaks on traditional machine learning algorithms that, for the same amount of data, make these algorithms perform better. And the third thing is specialized hardware, because it turns out that training these models requires a lot of processing power. And if we design specialized chips to do so, we can do it much faster at a much reduced cost. So what I'm saying, essentially, is that these three items made machine learning models so good that they are nowadays overcoming the ability of people to make predictions. They are better than us at classifying images, better than us at recognizing voices from sound, better than us at predicting several things, both in business to consumer and business to business settings. Essentially, what's happening is very simple, and it happens a lot in the economy. The cost of doing prediction is declining. And as the cost of doing prediction declines, three things happen. Prediction is used more. The value of substitutes declines. And the substitutes for machine prediction are human prediction. But at the same time, the value of complements increases. And what are the complements to machine prediction? Data and judgment. Because it's at the higher levels of the organization, us, that are going to decide where machine learning is deployed to solve what types of uncertainties and what actions are going to be taken when some prediction is unfolded. So it's not surprising that we are seeing applications and deals of machine learning in all sectors of the economy. The sectors of the people sitting in this room are overpenetrated, which is expectable. But we are seeing it all over, because just like the personal computer, just like the internet, supervised machine learning is a general purpose technology. You change the input data, you change the label that you want the machine to predict, and the algorithm adapts. The same algorithm that is used to predict churn in telecommunications is used to score credit in a banking system. And the investment in startups is skyrocketing over the last few years. We are seeing use cases of machine prediction everywhere in the economy, from financial services, media, retail, government, telcos, healthcare, gambling, you name it. And all of these examples that I'm citing over here are the same technologies being used with different input data and different output data at the end, different labels. Now, if you go through this table and you look carefully, you'll see that none of these are transformational. None of these are transformational. So it's not because the telecommunications firm will replace its heuristic rule of targeting clients that are at the end of the contract because they are more willing to leave, instead of using a score that aggregates the entire behavior of the consumer, that telecommunications firms will stop having a retention operation. We'll stop having people in call centers. We'll stop having door-to-door salesmen attacking or covering different regions of a country looking for new clients. Now, the telecommunications firm will deploy better its resources. It will reduce its costs, and probably it will contribute to shareholder value through better operations, more efficient operations, but their business will not change. So the question is, when will machine learning, when will these predictive technologies be game-changing for business? Well, I bring you an example that's not mine, but it's from two dear friends, A.J. Agarwal and Javi Goldfarb from the Creative Destruction Lab in Toronto. And it's an example of Amazon. And it's a thought exercise that I would like you to play with me. So, how does Amazon work? We sit on our laptops, we browse the website, we search for products. We add these products to a shopping cart, and we click purchase, we pay, goes to some fulfillment center, is packaged, and then it's distributed by FedEx or some other distributing company. Reaches our house, we open it when we are happy. Now, while we are purchasing these goods, we get something called product recommendations. Amazon is known for doing that. And I don't know if you'd be surprised to learn that a good recommendation algorithm has an accuracy in the order of 1 to 20, so basically 5%. So every 20 items that I recommend to you, you'll end up buying at most one. Now, imagine what will happen to Amazon business if they keep increasing the quality of their recommendation technology. Either because they collect more data on the consumers they already have, or because some algorithmic innovation allows them to recommend better to their customers. So at some point, the value of being able to predict will increase from 5% to 10%, then to 11, 12, 13, 15. At some point, it reaches 60, or an approximate number. At that time, someone at Amazon will say, wait a minute. If we know 6 out of 10 items that we recommend that this consumer will actually buy, why are we running a shopping then shipping business? Why don't we run a shipping and then shopping business? Why am I waiting for them to buy? Why don't I just ship them the goods and wait for them to return whatever they don't want to take? Now, this would make a lot of sense because it would increase their share of wallet with all of us. We would buy the 6 items that we want, and we would buy all from Amazon instead of going to Fnac, Vorten, or some other retailer that we could going through in our lives. Now, I'm looking at your faces and trying to see your reactions, and some of you are laughing and saying, this guy, they invited this guy here to talk about science fiction. Well, you know what? It might be the case, but someone at Amazon has given it considerable thought. What I'm showing you here is a patent that Amazon filed. It's called a patent and method for a system of anticipatory package shipping that describes exactly what I've just told you. So Amazon has someone inside thinking about what could happen to their business if the quality of their prediction algorithm, if their recommendation algorithm increased so much that it would disrupt the way they do business. Because a shipping then shopping business is completely different than a shopping then shipping business. Amazon currently doesn't own the last mile of distribution. In this type of business, it would have to do so. So the way they do business would completely change. So this brings me to my last slide. What really have I been telling you for the past 18 to 19 minutes? Well, you know what? Not much. I just told you that the cost of prediction is declining because we have more data, better algorithms, and more computing power. And when that happens, when the cost of a good declines, it's going to be used more, especially if that good is general purpose, as supervised machine learning is. Now, will this change your businesses? I'm not sure. It's for sure going to improve your operations. I have no clue about that. Now, whether or not you'll find use cases like Amazon is mostly up to you. So I'm an academic. I like to assign homework to people. So I'd like to assign you a homework. To each and every one of you here. Go to your jobs, sit at your desk, and write down a list of tasks that you do. Highlight the uncertain component of some stuff that you do. And think carefully, how would I do my job better or differently if somehow this uncertainty that I have would be resolved? Do you think any of those uncertainties could actually be resolved by technology? Because if you do, if you see those things happening in the short term, then you should be investing in these technologies right away. Thank you very much.